Hey guys, welcome to the last video on Diels Alder. So we covered everything. The last thing I just want to cover is a retro Diels Alder. So what does that mean? That's just the reverse of a Diels Alder. What they'll do is they'll give you a product and they'll ask you what are the reactants that gave this product. All right. So again, we're gonna have to go through a couple of steps to do this, right? But hopefully not too bad. All right. So there are some tricks to getting through this. So let's redraw what we have. And if you want to try this on your own before you watch the video, please feel free to do so. Or just pause the video. Alright, so how do we do a retro Diels Alder? So let's think about this first, and then once we've thought about it, the tricks will make sense. In a Diels Alder, we start out with the diene and some, let's say, dienophile. And what we're going to get is this ring with the double bond now moved over there. And I'm not going to draw the stereochem, that's not that important right now. Let's number them 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So let's look at this. Carbon 2 and 3 on the product has a double bond. The dienophile originally had a double bond on 6 and 5, and that disappeared. All right. And we had double bonds on between carbons 1 and 2, and 3 and 4, and that disappeared as well. So what you can kind of do is this double bond needs to end up, needs to end up on carbons 6 and 5 again, right? Not, remember this wasn't the actual double bond. So carbons 3 and 4 moved up like that. But I'm saying you can think about it how this double bond, we can kind of shift it across to carbon 6 and 5. And now we have our dienophile, right? And then we can just draw a double bond between 1 and 2 and 3 and 4 to get the diene. So here's the trick, all right? Let's redraw this. So here's our product of a Diels Alder, generic product. The first step is shift the double bond across. That's step 1. Let me number this 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And let me even draw in like a methyl group or something over here, just so we can keep track. Alright? So that's step 1. Shift the double bond across. Step 2, redraw the double bond of the diene. So that should be between these two carbons and these two. Right? So like I said, step 1, the double bond moves directly across. Then you look at that where that double bond used to be and put 2 double bonds on the 2 carbons next to it. Alright? That's step 2. The next step is to cut those bonds away. Alright? So we break those bonds. And just to renumber so you guys can see, 2, 3, 4, 5, 6. Alright? So we did this. Now let's do it in an actual problem just so it can make sense, alright? So here's our Diels Alder product. First step, shift that double bond to the other side. That was a really bad ring. Here's that double bond. Now we draw 2 double bonds next on these carbons right here. Right, where next to the carbons where that original double bond used to be. That's step 2. Step 3, we're gonna break the bonds right here, next to those bonds next to where that double bond that we shifted. Now you'll notice I kept the stereochem even though they're, let's say the diene is the diene file, right? I kept stereochem on that double bond. We know double bonds don't have stereochem. The only reason I kept that there is because we haven't figured out the stereochemistry of what the original reactants are supposed to be. All right, because remember that does play into effect here. So on our diene file, if you look at the Diels Alder product, where our diene file was, these two, that methyl and that withdrawing group, have the same stereochem. So remember, if you guys remember how stereochemistry works, on the original diene file, they must be on the same side of the double bond. So what I'm going to do is I'm going to make them planar. Right? Let's say I just put the withdrawing group there. Because the withdrawing group had the same stereochem as the methyl, we need to have that methyl on the same side of the double bond. All right? So that's the diene file done. What about the diene? All right? The diene, if you look, remember, we want these trans groups on our diene, these two groups, to be the same side as the electron withdrawing group. In this case, we had this wedge, methyl, and it was opposite stereochem of the withdrawing group. So what does that mean? Well, we know that if the trans groups have to be the same stereochemistry as the electron withdrawing group, then the cis groups would be opposite. And so, because the methyl was opposite the electron withdrawing group, it is not going to be the trans group. It's going to be the cis group. So we have to turn it inwards. All right? So if they gave you the product where, let's say I drew this, right? Then we would know that, okay, because this group is the same side as the same stereochem as the withdrawing group, it must be in that trans position. So then I would have drawn the product where that is sticking outward, but it's not, so we put it inward, and that would be the answer to this question. All right. Now that we have that done, let's go to another question. Now this is with those weird, wacky three-membered, so 3D structures, right? But the steps are exactly the same. So let's see if we move this up a little bit. All right, so let's redraw. Now I want you guys to notice something. We have two rings, and you can see that it's kind of bordering it, right? So first step, always move that double bond across. So in this case, you can see that it's kind of going to be moving over there, right, across it. It's probably a little bit easier to see it on here. So I'm going to just put a dotted line. Let's redraw again. Here's that double bond. Now we draw two double bonds where over here, right? Those two bonds. So it's going to look a little bit awkward. All right. Next step, we break these bonds right here. And that bond. All right. And so that's going to be the bonds that we're breaking. So let's redraw it. Keep it all the same. You're going to see why in a second. It's going to look a little bit odd. But, and let's number. So it might be a little bit easier to see if I numbered 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm going to put that carbon as 10. 1, 2, 3, 4. That was 10. Now I broke that 4 and 8 bond and that 1 and 9 bond. But look, we still have this chain connected to everything else, to that to that diene because carbon 4 is connected to carbon 5. All right. So 4 is connected to 5, which is connected to 6, 7, 8, and then 9. And you can see that 9 had that double bond, so that was where our diene was. Sorry, dienophile. All right, now what we want to do is we just want to clean this up. All right, so if you count the carbons, we have 1, 2, 3, 4, and now 10 was part of that ring, but I'm going to say 5. So we have a 5-membered ring. That was bad. All right, so let's number 1, 2, 3, 4. That bridgehead was 10. Carbons 1 and 2 of the double bond, and so does 3 and 4. 4 was connected to 5. 5 was connected to 6. 6 was connected to 7, which was connected to 8. And then to 9, and that's where our dienophile is. Okay? So that would have been the answer to this question, right? What's the reactant that produces this Diels Alder product? Now, one more question, right? And let me just move this up a little bit. Draw the structure of the reactant that would give the following tricyclic product. All right? Again, it may look a little bit complicated, but don't freak out. All right? So what I'm going to do is I'm not going to redraw this one. So let's see. It says, it gave us a hint. The ester group should be attached to the dienophile of the reactant. All right, so we know that the ester group is 100% part of the dienophile. So our strategy is always to move the double bond across this way and put that double bond there. But if we did that, let's draw this. All right, so we're going to have this. That's our double bond. And here's our CO2ET. All right. We would put 2 double bonds here as step 2, and then we would break these guys. Now let's draw the product. That was bad. Alright, I drew it a little bit awkwardly, but the point I want to get across is that if we did what we just did here, you wouldn't get the CO2 on the dienophile, that ester group on the dienophile. We'd get it on the diene, right? So, well, not really technically on the diene, but it's going to be way closer to the diene than the dienophile. So what we're going to do is we're going to still move the double bond across, right? But I want you guys to try to picture this. It's going to be a little bit odd, but remember how I said in the when we talked about cyclic dienes, how I kind of popped one part of the ring upwards, right? And so usually that was this case. But what they did instead is they just brought it downwards, all right? So this is our 6-member ring, the original one. All right, so they did it the opposite way, and so I'll show you in a second. So what we're going to do is we're going to move the double bond across, but it's moving across up to here. So there's the dashed line. I know this is a little bit tricky to visualize, but this is probably one of the harder questions like this, all right? So I'm putting that double bond there. Step 2 was to put the double bonds here. And now we have to break the those double bonds, or we have to break those single bonds. Now, in this case, we have to break those. Remember, we break the ones adjacent to that diene file. This one and this one. So I'm going to redraw now. And hopefully when I show you the product, it will make sense what I was talking about. One, two, three, four, five. All right. And so this is what I was talking about. We have that CO2 ET on the diene file, right? Which is exactly what they asked for. So this is exact. So this will be our product. But what we did here is this was our original diene, and you can see that it's that the front part of it was kind of pointed downwards. Usually, what we do is we have it pointing upwards, so something like this. Like that. And instead, what we did is we drew it like this. Oh man, I can't draw today. All right, pointed downwards instead of upwards. All right, but it's still the same thing. All right, they just tried to mess with you guys a little bit here by making it like this, but they did give you the hint. So with the hint, this was definitely a doable problem. All right, and so just watch out for this because they might not give you the hint this time. Right, and in general, you should have been a little bit thinking that this is a withdrawing group, the ester. So we probably should have it on the diene file. All right. Hope this video helped you guys with how we do retro Diels Alder. All right. And so that's going to be it for the Diels Alder series. In the next video, we're going to be covering aromaticity. All right. I'll see you guys in the next one.